Today, we have three aspects to discuss here. The first aspect is the assignments now. Let's start our assignments now. So most of you by this time must have finished up at least the first part of our course here, which is ad hoc thinking. So how to solve problems with ad hoc thinking here. So I'll take up the assignment here. The second part of this live session will take it up. The common paper, normally you see it up. So these assignments covers mostly interview questions now, but sometimes to filter you, they give some online test with objective questions also. But what kind of questions they expect you here? Once you really see the real paper, you get a clarity on that. Followed by, I'll take question answers and everything. So that's what the three parts I'm dividing this live session here. So the first thing here is so our assignment here. So I think the first overview videos are there. After that, the first thinking I have discussed was ad hoc thinking here. So before really doing assignment, I always say that go through these problems which we have solved in the ad hoc thinking here. So once you follow those videos now here, you really get the basic thought process for simpler problems. How do you get it up? So don't worry. First time when you really started learning coding here or algorithms now, first day I want to get all the best thoughts in this world. It's not possible because your mind is not tuned to think in the direction here. Maybe from the kind of education we have it up, it's so bad that we never have given opportunity here to think about a problem here. It's all theoretical here, which is completely useless and everything. So when you switch from that direction directly, straight away into the problem solving, your mind will really, so always rejects that kind of thing here. You got to understand, you got to make your mind to see what is reality here. Slowly, once you understand the real importance now, you start tuning this direction. Take some time, a week of time or 2 weeks of time, some people to adjust to this problem solving mindset. Without a problem, there's nothing in this world. You got to learn it up. The problem is given. If you do not have skills to learn it up, you learn from somewhere, either from book or from your friends or from videos or wherever you go. If you don't have a problem, what do you want to learn in this education? That's why. So the aspect here is, don't bother too much. First day I cannot get solution for first assignment. Most people get fear. This fear is the biggest pain. Your mind, once it doesn't accept the new thing here, it starts creates fear. It's difficult for me. So who is saying difficult? Your mind. But once you really slowly, be peaceful, be calm, just look at some bunch of problems now, understand thinking style, start enjoying that. Once you start feel enjoyment here, the mind automatically attracts it out. That's the only way. Be calm, be peaceful here. It takes some time to adjust to this mode. That's why. So some people who really get struggle to really enter into the algorithms or problem solving mindset, this is all you got to do. There's nothing difficult in this world. Anything in this world created by some mind, your mind has to understand it. Where is the difficulty? That's why. That's the truth of what they call, how to really, what they call become a very, very good thinker. So everybody have a thinking capability, but you never used to try in that way. So with that, now assume that you first must have finished up at least ad hoc thinking, the basic problems I have discussed in the class. With that background here, you must be able to solve at least all assignment questions, practice questions. When you get a time extra, you can solve it. But at least as part of the course flow, I recommend to really finish up the assignments now. I'll discuss some of them here. So you can download the paper here in the description section, the YouTube here. If you don't have the link, I'm just taking the paper here. So the first question I'm really taking out here is reverse words in a string and everything. So how do I reverse words in a string? So that's first problem. Second problem is find all anagrams in a string. You can check here. So third problem is merge sorted arrays now. So I gave already, before solving these questions, first understand the solution building strategies and coding for the problems in live or a video session. Since currently, so all is online innovation, go through the videos now, first finish it up and do the coding innovation. Just don't listen it up, just like, listening to theoretical subject and it's no use. Whatever problems are discussed, ideas now here, you first code it. After some enough coding experience now, then you don't have to really worry about what they call coding. But initially, if you don't code it up, you don't get, the details and some of the interesting ideas normally when you write a software. I recommend coding, no pseudocode, nothing. Start coding, write a software. So there's an exception, there's no, so there's no other workaround for it. So then after that, now you got to really, start coding it up. That's what clearly told you here. Don't directly pick up this assignment here because you don't get thoughts, because you never know how to think basically. At least some thoughts I introduce here. Slowly you can think of new ideas with combinations, permutations of that. If nothing is there in mind, how do you get a new thought? So the first problem, let me take it up. So given a string, you need to reverse the order of characters in each word within a sentence while still preserving white space and initial word order. Say very, very, simple and straight problem here. Just given it up, data like this. Let me write a problem 1 here. So I divide this into sections and everything. Write this problem 1 here. So the problem 1 here is reverse words and everything in a string. Always before picking up the logic, take some data here. Let's say I'll give it data like ABC, so DG here, so FGH. This is a string. I'm asking here, don't change order. So ABC must be ABC only, but you have to reverse it up, CBA here. Then DE must be ED here, FGH. Now what we expect here is, HGF. So this is all I'm asking here, without changing the what they call initial word order, still preserving white space. And also each word is separated by a single space. There will not be any extra space in the string. Don't worry about extra white spaces. So that's a much simpler note also given to you. Now once this is available, so what do you have to do now? It's a very simple thing here. One scan is enough here. So first you go to the till white space comes up here. Once the white space comes here, reverse this what they call a characters. If your input is mutable, then it's straight away you can do it up. Let's say here in this case, I didn't give the syntaxes. Different language you pick it up. Maybe in Python, if you pass a string as input, it is not a mutable thing here. But Java and other languages here, so you can pass an array of characters also here. When you do that, then the mutability is available, so you can directly, so there itself you can able to reverse it up. All you have to know here is, so start and end positions now. Go to start, go to the, empty space, blank space, sorry. One space comes out here, stop there till that point, reverse it. So swap the characters, move forward and, until you get the reversal here. Once you finished up, again, when the next character, again, next non-white space comes out here, start index, go to the end, space comes up, stop there. Now again reverse it up, you get it up. Again we go to this F here. Now once end point comes out, stop there, then again reverse it up. Just one scan is all we require it up. You can able to finish it up if it is immutable. So if you can use libraries also. Now why should I really not do manual here? Why can't use libraries now? The coding could be multiple ways now here. You can tokenize it up here. Each word comes up, reverse it, you can join it. But question here is when immutability is available, so that's where you got to think of all this external work and everything. When immutability is available, one scan, no extra space, nothing here. That's where a lot of options are available to solve this problem. It's not too much algorithmic problem here, just a bunch of varieties you can think of how you can able to do reversal of each word. So just 2 indexes you can able to manage up the whole work. So reverse function, write it up. Now keep calling whenever you get start end indices. Now the complexity of this is clearly here. So we need at least one scan here, theta of n, compulsion, and constant n is enough. That's why write theta of n. Space complexity here is, now I'm not using extra space if it is mutable. If it is immutable here, then you may require an extra space. That's what the first problem here. There's no other difficulty in the first problem. Let's take a problem number 2 here. So this time I'm asking here, find all anagrams in a string. Let me write the problem statement. Find all anagrams in a string. So anagrams, again, in one of the videos, I must have given it up, the definition of anagram and one of the simpler problems anagram. But here, so whether are you able to understand the ideas or not, I'm testing why this problem here. Here, the data was given here. Let me write this data, CBA. then EBA, then BACD. This is what they call S. P I have given it as ABC now. So what we are asking here is the start indices, and we should find all the start indices of P's anagrams now. ABC, what are the anagrams possible? All permutations now. Since 3 distinct characters are there, 6 possible permutations are available. ABC or ACB here, BAC or BCA, CAB and CB, any of that. So wherever they are available here, so that start positions you are written up. Let's say CBA is here. This is definitely one of the anagram available. Start position is 0. BAC is available here. This is also start position. Anywhere else in middle, nowhere else now here. There, how are we going to do now here? Maybe one strategy could be, first you would find what they call all anagrams of this ABC here. So how are you going to find anagrams of that? So ABC, CBA, all permutations you have to find it up. After finding all permutations and here, then you got to check it up. Each of that. Now again, each position you have to try all of them. But this is definitely laborious work. So the key here is, this is a kind of a naive strategy, you can think of it. But if you recall the videos, the ideas we discussed, to check to guys anagrams or not, we are given another tricky part called signature match. If you want to check anagrams now, you don't have to check what all permutations now. Sort the characters. If the signature is same, they can always will be call it as anagrams of each other. That's why here CBA, ABC, whatever is available, instead of finding a permutations, keep ABC, sort it out first. That's why ABC we sort it up. It's already ABC and ABC. Now what do you got to do here? Go to the original string. So go to the first position here. Now here, first sort it. How much length? 3 characters now. Definitely take 3 characters now here. Then you go to what you call sort it out here. After sorting this, ABC comes up. ABC here, we got a match. Once you got a match here, now take this position, return this position, maybe store into a 0, a result. Next, move forward here. So once you move forward, again, next 3 characters are BAE and ABA. BAE, again, is it anagram, is this anagram of P is available or not? To know whether these 2 are anagrams or not, sort it up, ABE comes up, ABC now, that doesn't match it out here, ignore it up. Move to the next position. Next position is AEB. AEB again, when you sort it up, ABE comes up, but ABC is not available. Like this, if you continue it up, so when you come to the BAC position also, this position, BAC when you sort it up, again ABC is available, so they're exactly matching it out here. Now, again we can say that position also will be added to the result. So 0, 1, 2, 3, 4, 5, 6. 6 is the other value. So there is no other place where you got this exact, matching here. So that's why the tricky part here is, now whether should I compute the permutations, verify all of them, or use that signature concept where when I sort it up, things become simplified. So that idea what you see in the actual discussion in the class now, must be able to bring it out to solve this problem. That's why one scan this array is required, and again, so one scan and also sorting of each of this, each position now. So that's how you can able to get the whole solution. That's what they're asking out here. You got to return. And the size also is very small here. They're asking up, length of string is 20, P is what they call 100 maximum here. That's why. So even this simple algorithm is also okay here. You don't have to really, discover any more efficient algorithms here. That's more than enough here. That's all about find all anagrams in a string, the starting positions here. So that's what second problem here. Code it up here. Initially when you start your learning here, please code everything here. If you stuck up, always you can ask here. But without coding here, first few sessions here, you won't get clarity here. That's what second problem here. So third problem is merge sorted arrays now here. So let me write a problem number 3 here. We call them as merge sorted arrays. So merging is very, very simple thought. Again, some of the videos I explained the essence of it. But here, 2 sorted arrays, you got to combine as 1 sorted array. But what type of arrays they are giving it up. If I see it up, so the first array here is 1, 2, 3 here. Then 3 zeros are available. Then second array here, we got 2, 5, 6. So you got to combine, both of this into what they call in this starting place now. That means the 3 zeros, whatever is available, you must able to fill it up here. So the output expected here is 1, 2, 2, 3, 5, 6. This is what input here. This is what output here. So both are sorted anyway, guaranteed here. So how can you combine two arrays into one array here? If there would have been separate third array here, then obviously I can do things very easily here. I can take two indices now. Since my aim is to get sorted output, which of these elements are possible candidate for the first smallest anyway here? Since always sorted, first two elements are only possible candidates now. That's why we take two indices normally. We take smallest of them, which is 1. We bring it up. Next. So we move forward here. 2, 2. Why we are moving forward? Because once it is over, next possible smallest will be either this or this. That's how we compare it up. We move forward here. Then 2 and 2 here. Again, so both are equal. So you can copy this. So, or you can copy both of them also here. Not an issue here. So once you copy them here, then we move on to this next guy here. So 3, 5, 3 is smallest anyway here. So once 3 is over here, move forward, nothing is there. 5, 6 you can copy. If the array is separate array, this would have been super easy here. But the tricky part is there is no third array here. So 2 arrays are given. First array only I want the output to be available. That's why. So any interview normally, this kind of tricky things will always be there, either test or interview here. That's what you got to really catch it up and solve it. So how are we going to do now? If you do left to right anyway here, the pain point is what now? If you want to copy these elements now, you may lose the original values now here. If I try this way, 1, 2, 3, 0, 0, 0. If I keep it up, 2, 5, 6 now, 1 and 2 smallest, 1 is available, 2, 2 no problem. If you copy 2 here, then I need to take off here. Next, if one more element comes out here, so that means what? Original array. So original array, I may lose elements now here. Since I don't want to lose the elements now here, what do I do here? A simple strategy is, instead of going from the smallest element here, because we got empty space here, why can't use this empty space now? That's where what you do here is start from reverse direction. It doesn't matter which way you go it up. So now the largest element is what are the possibility. Instead of asking who is the smallest out of these two arrays now, what element is largest of these two arrays now? If you see either this or this, so the largest of the 6 now, you copy as the last position now, you're done with it. Now we don't have to bother about space issue now. Now reduce or get back this index now. So one position left, 5, 3, 5 is the next largest, copy here. Now once the 5 is done, now we are here. 3, 2 now, 3 is the largest now, bring down here. This index you move down. 2, 2 now. So both are same here, you can bring down here, again 2 is already there, now you can here, now we are here. So this element is also finished up, now we reached up to the end of this. Once you reach end of that, element 1 is in the right position now. The output is 1, 2, 2, 3, 5, 6. That's what expected output anyway. So instead of finding smallest of these two, find largest of the arrays now. So the space I can utilize it up. If you go from left to right, also there's a way you can do it up. But always when you bring this element now, this element while overriding up, where do I keep it up? So that's why maybe I need to keep over here. So that extra unnecessary headache can be taken off if you come up in the reverse direction. That's what a single scan algorithms here. So complexity is just n plus m. If n is a size, m is a size now, n plus m is the complexity. That's why complexity here, right, of is theta of n plus m. Space is going to be constant because they are given that space to you already. I write n plus theta because the minimum maximum for this scan will be n plus m only. So that's all about what they call this merge sorted arrays requirement. So the fourth problem is remove duplicates from sorted array here. So let me take up space here. So problem number 4 is remove duplicates from sorted array. So how do I really remove duplicates from sorted array? Let me give an array as 1, 1. This is very small example. I'll give a little bigger thing. 2, 2, 2 here. 3, 4, 5. So assume this is what is given here. 1, 1, triple 2 here, and also 3, 4, 5. This is sorted array. That's what I'm asking. All you have to do is remove duplicates from it. You should not allocate extra space. You must do this by modifying the input array. What you have written here is just a new length. So you don't have to bother about what is after that, duplicate removal is done. So what do? So let me try first of all. What is the naive strategy? Always say first get a solution 1. Maybe this Adhoc thinking, even simple solutions are more than enough. But when the complexity keeps increasing, first getting a working solution is most important here. Now, what do you do here? How do I remove duplicates? You start from here 1. You compare with the next element duplicate. Duplicate, I cannot remove it up. If you start remove it up, then I should shift all the elements now. The naive strategy of removal is, I know duplicate very straightforward. Left, right, just scanning, adjacent elements, scanning and comparing adjacent elements is more than enough. But when you compare 1 here, if shifting all elements is a painful. After shifting again 1, 2 are not equal, 2, 2 are equal, shift. This is a naive strategy. But this, will take a lot of time if n is, very big. So obviously here, without shifting the elements, now if you can find some strategy, definitely acceptable here. All these problems, some tricky part will be there. The tricky part you have to catch it up. So first try working thought. Maybe let me show you naive thought anyway. What is the pain? Remove 1, shift all of them, 2, 2, 2, 3, 4, 5. Now still I am here. 1, 2 not equal, then shift to the 2. 2, 2 equal, again shift. Shift means what? 2, 3, 4, 5. Then again 2, 2 equal, again shift here. That means 3, 4, 5. 2, 3 not equal, move to the next guy. 3, 4 not equal, shift to the next guy. 4, 5 not equal, shift. 5 end of the array. But each time to move it up here, so how much time it's going to take it up? That's what the biggest pain here. Maybe worst case, if you think of this input and everything, if all are ones now, what will happen? 1, 1 equal, shift all, n minus 1 elements. Again, third one, n minus 2, n minus 3, n minus 4. Worst case here, this is going to take it up, n square complexity. So that's why, we call it as, the state of n square. This is a naive strategy. We don't want, naive strategy. Instead of naive strategy now is, n square algorithm here. If you can able to do in one scan, this so-called remove duplicates now, this is far efficient now. So how are we going to really get n algorithm now? So let's take the data. Instead of shifting, what do I need to do? So here 1 is available. When 1 comes, we know that is a duplicate anyway here. That's where, let me introduce here. So this 1 should be available. This position I really call it as what they call, maybe just take the input again to illustrate. What do I do without shifting this data? So this position I call it as a non-duplicate position. Last non-duplicate, what is it? So 1 is not a duplicate because no previous elements. So I take one more index now. I compare here. This is like current index now here. Anywhere when I say refer current, meaning that refers to the current element in the array. Giving a useful naming convention will simplify our expression of thought. So this is going to be last non-duplicate position and everything. So this current keep on moving up, starts from here, 1 equal to 1. When equal to 1, we know that this position need not move it up because that it's having non-duplicate anyway. This is indication of duplicate. Don't do any work, move forward. That means current goes to 2. So no shifting, nothing. I'm moving my pointer and everything. So now 2 is not equal to 1. When 2 is not equal to 1 true, it's definitely what they call not a duplicate anyway. This time you got to bring this definite second non-duplicate element. It's a sorted array, no need to bother, somewhere else it is available. Just bring it up to the next position after the previous last non-duplicate. This is the position. Now I'm going to bring to this position. So try to copy this 2 here. Current moves on here. So current is going here. Now 2, again last non-duplicate is 2. 2 equal to 2 now. Duplicate, ignore it. 3, don't shift elements now. Equal to 2 now here. Again duplicate here, ignore it out here. Next 3. So 3 is not equal to 2. When 3 is not equal to, again we got a third non-duplicate element. So copy this here. Next position. This index will move here. So after 3 is over, next 4 we are going out here. Again 4 is not equal to 3. Bring it out to the next position. Then again current goes next. 5, bring it up. So end of the array, stop there. So whatever the number of elements index now, so 0, 1, 2, 3, 4 plus 1 is what the number of distinct elements now. You written that as what they call a final answer in a wish. That's what ideally. So what is expected here of this problem? What is thereafter? We don't have to bother. That's what problem statement says here. Just give the size and a wish. So this all requires one scan and a wish. So the only thing is the 2 pointer, when the second pointer, second index variable makes sensible. So instead of shifting, second variable takes care of it. The first variable points to the last what they call a unique number in a wish. So that is what makes this solution what they call acceptable in interview or in any competition. So this is state of an algorithm. Time, space, we are not doing extra, 2 variables are using, that's what they're asking, constant space here, we go for 1. So that's what you call problem number 4. Next, shortest distance between words. Let's understand what is the meaning of shortest distance between words and a vision. I call this as problem number 5. So given a list of words, that's what they're given. One list is given and 2 words, word 1 and word 2. Written the shortest distance between these 2 words in the list. Word 1 does not equal to word 2. Same thing, they're not giving it up and they're definitely available in the list. You don't have to bother about non-existence also. So they're given a problem, practice makes perfect, coding makes. Coding and practice, if you give it up, maybe let me write this example. So practice here is first word, second word is makes here. So third word is perfect here. So fourth word is coding here. And fifth word is again makes. So coding and practice they are giving out here. If I give coding here, this is definitely available, practice here. Any 2 words of course, W1, W2. So they want a shortest distance now. Okay. So what do you mean by this shortest distance? They can appear multiple places now. In this case, practice, coding makes 2 times available. Even these words are available any number of times now. So in this case, the distance is going to be 0, 1, 2, 3 here. The gap is going to be 3. So only one possible existence now. 3 minus 0, 3 is all they really want it up here. So, but question here is, what is the naive strategy? Always I told you that, before going for efficiency, think of a naive strategy. If W1, W2 are available, how are you going to find a distance now? And simple logic is, first find where W1 is there. If W1 is available, let's say somewhere here, stop there, check in the whole array where W2 is available. Wherever W2 is available, then find a distance now. Find a distance now. Out of all, maintain a smallest distance anyway. Indexes are available. You can always take a difference now. In this case, first practice is given, let's say, I found practice. I take what they call W2 whole array here. I compare it is coding now, it's coding now, it's coding now, again it's coding equal. The gap is going to be 3. Next, makes now, it's not coding here, then leave it up. Then after practice now, check practice again here, wherever is available or not. Makes is not practice, perfect is not practice, coding is not practice, makes also not there. In this case, it is straightforward in a vision. That's why one simple idea is, NSQL algorithm is so easy now. So if number of words are n in a vision, if these 2 words are available, assuming length of the word is a constant, some 20 or 10 characters now, we don't have to really compare the timing, or we don't have to include the timing for string comparison anyway. If you want to include it, that extra multiplication comes up. But assume for a moment, it's constant time share, constant length. Once constant length is available, first word you find it up, maybe just make one loop through, the each word. Once there is a match, second word again one more loop here. This is n-square complexity. Surely you can get a working solution for that. That's why the naive strategy is simply here. We call it as, n-square. Space we don't need extra. But again, tricky part of most of these questions are, instead of n-square, can you bring down this to an algorithm or not? If you can do that, either interview or in mostly the competition, it will be acceptable. The tricky part always there in this interview questions of this programming programming round here. So let me take up. So what can be done in this so-called naive thought here to simplify this n-square complexity? So let's take up that. Maybe I just write in this fashion here. So W1 W1, W1, W1 here, somewhere W2 here. So W3 is there, W2 is there, again W1 is there. Just to simplify things now, how can I reduce n-square complexity? So given this, now my input is W1 comma W2, find shortest distance, here is 1, that's all our answer here. But naive strategy, what are you doing here? First is stop W1 here. Now you're comparing where W2 is there. So this W2 is there. So gap, we take it up. This is, let's say 0, 1, 2, 3, 4. Now, let me just take one more here. W1 here. 4, 5, 6, 7 and over here. 7. Now first W1 here, W2, 4 minus 0, 4. Next, finishing that, I compare this W2. But this is useless anyway here. That's what you can observe in n-square complexity. Once you find W1, next W2 word anyway here. So this W2, once we found all words comes after that, will give more distance than that. Why should really waste our time on moving that? That is one key observation which you are doing up n-square algorithm here. That is completely out. Now after finishing this W2, W2, now we continue with the next W1 here. Next W1 is somewhere here. Again then W1 is available. You start searching here. For what now? Next W2 here. So if you see next W2 here, again next W2 somewhere here. Again you find what they call the distance here. Next W2 again here. This is useless here. Again I finish in W1. Again next W1 here. But out of all these W1s now, why are really wasting up our time on all of them? Out of all these repeated W1s, W1, W1s, now if you skip all, what matters is, what is the W1 closest to W2 anyway here? That means it's in the n-square algorithm, we are not doing up all this optimization anyway. But if you see what is the pain in the what they call naive strategy, more data if you take it up, that observations might help you to get a better algorithm. There are no other shortcuts now here. So W1 is unnecessarily wasted up. This W1 checking this W1. The closest to the W2 here is somewhere W1. This distance matter. And again, for these two, the distance matter. Both are, of course, one distance level. That's what ideally one output expected up. But in naive strategy, we are doing up this W1, all of them unnecessarily. So that's where, what are we going to do now? Instead of going for W1 match and taking second loop for all W2, what do I do here? Simply, so start with W1. Now check it up next guy here. So this W1, you found it up, okay. Next guy also W1. Next guy is W1. This old W1 is completely useless for us. That's why all you can do is just skip it off, move on to the next W1. This is useless. Whatever W2 next you are going to find it up. With this, the distance will be more than this guy. What are the use of considering that? Ignore it. Again W1 is there. So useless now. Move it up here. Again, next W1 is there. Again useless. You stop here. But next time when you go it up here, this I call it as, let's say, the first word index. And I call it as, let's say, first word index. Now, next guy is W2 here. Once W2 comes up here, I cannot take off this here. So W2, again, I'm important because that distance is required. So I found W2, but after W1, when W2, any number comes up, only first thing matter after W1 here. Remaining things are useless anyway. It's first time I see it up. This is second index now. It's available at this point. Gap is 1. Maintain this gap 1. Then after that, what do you do here? Next. So one loop, one movement is happening. This movement is over again. So now we are here W3. So W3 is not matching either of it. Just ignore it. Next, again W2 is available. When again W2 is available, now what do you think? Already W2 is available here. So now again W2 comes here. Now which is useful? This W2 index, what is second here, is no longer useful. Why? So this W2, what might be helpful is W1 comes later on, that distance makes sense. This W2, this W1, no use anyway here. That's why once you get next W2 here, the second index, what you are maintaining up, move forward here. That's where we are here. Now again W2, next W1 comes up. This index is definitely no use anyway here. This guy also update. Now again, when both second and first are available, what they call at any point of time, take the gap. So even before gap also take it up. Maybe here when W2 is there, 6 minus 3, 3. It's not smaller. 7 minus 6, 1. 1 is smaller anyway. So the interesting observation over here is, so in the basic or in the naive strategy, after taking W1, blindly we are taking W2, which is not required. You got to skip unnecessary W1s. After W1 is over, one index is maintained up. Next time when a W2 comes here, first W2 makes sensible. Any W2 which comes afterwards here is just what they call or will not help you. Even if you take them, the distance will not be more anyway. That's why keep moving up this index anyway. Again when W1 comes up, update this index now. At any point, these two gaps, maintain the smallest value here. That smallest value is called shortest distance anyway. This is single scan approach here. We call it as theta of n. We need two variables to know W1, W2 indices. One current index should be required to move forward. That's where constant space is required. This requires little time. It just cannot be derived up in 5 minutes anyway. It takes a bunch of examples. Go detailed about what's the problem over here. So now we're discussing, it looks very simple here, but while building a solution now, it takes a little time. But once you do, keep doing it up. Next time in a new what they call similar kind of problem is given it up, you know how to derive better solutions. You cannot really go to the problems large number at short span. You got to take problem very detailed way, spend more time on thinking than covering large number of problems. More time you spend it up, your thinking process will increase here. So you should not rush. That's a key in algorithm skill while building it up here. So that's why problem 5 also you can build up a n timing here and also constant space solution. I think most of these problems here, so we are really getting some kind of tricky solution. That's what I accepted for interview as well as the in a coding competitions. Mostly these are taken from LeetCode. So that is accept the test case are written such a way that if you write an algorithm only, they'll accept it. Otherwise, they tell you some time limit exceeded issue. So that's what the problems of first assignment here, which is ad hoc thinking assignment here. Okay. So go through again in these problems. If any questions now, you can post Q&A over there. So that's first part of what they call our discussions and innovation. The second part of our discussions here is going to be, I'm just logging in innovation. Yep. So this is a test series innovation. So I given the paper at the description section of YouTube. The purpose of this paper was, so in assignments are given, most of them are interview questions asked in the top companies here. But sometimes there's online test they're conducting up international any company. They make round 1 here. They filter a lot of people. Then they go to round 2. Or instead of phone interviews nowadays, this online test becomes more common here. So online test means mostly some of them are objective, some of them are subjective innovation. But what type of questions objective they'll ask you, that is not shown anywhere in assignments now. The tests are showing up typical format. Most companies follows here to clear a different rounds. Entry questions anyway, all assignments will be of entry question nature anyway. So this time limit is there. So once you go to their portal, whatever company recruiting up, they give you time limit here. I given 75 minutes time limit for this paper. But this is mostly top 20 basic level here. I didn't give up advanced pro level of standard innovation and instructions. Please go through that, what is the purpose of this test. But if you look at the sections now, normally they divide into 4 sections. Most companies across, they follow this kind of format. First section is data structure applications now. They give some kind of requirement anyway. That requirement, how do you really satisfy with particular data structure? After finishing top 20 basic course, then you attempt this paper. I thought of discussing here, but I feel that if you finish top 20 basic completely, then you can understand, the complete Q&A or the complete, answers to this question here. That's why I really recommend, I just uploaded just now here, maybe you finish up what they call, by end of this course, you attempt this test and it takes 75 minutes. You do like a realistic test anyway. Under pressure, how do you really think about it? This will be like a practice test. And time limit also given for each and every section. First is data structure application. Second part is time complexity. Again, I want to discuss that, but I want to give some more time because a lot of recursive calls are used up. Unless you don't finish up recursive topic here, it's difficult to understand even if I discuss this paper at this moment. But you can see the level they really ask you. They never ask you what is it, what is that. That kind of question out. All you got to do here is you got to think. Every problem you have to really apply. While learning things itself, you got to learn that way. So once you learn the top 20 basic program, this kind of papers, 100 papers, even if you give it up, you should have confidence to attack it up. A new problem, you should have a confidence. That is our ultimate goal. While learning, if you keep thinking in the direction, it's just again, different kind of application only. And third section, if you go there, and it's bug fixing. I see this kind of interview clearance, asking questions. A lot of companies nowadays, because they test your coding skills also. If you've done a lot of coding and you have expertise, bug fixing also, you have skills to come up quickly. And this bug fixing question also logical, and you need a skill too. So there are each of them 4 minutes now. And final section is our actually subjective questions, where we are discussing all our assignments now that for a test or interview, both forms they can use it up. This is mostly the algorithms and programming test, or programming online or offline, whatever way they conduct it up here. Language questions we are not including. Language series will discuss language questions now, how to really tricky questions in a particular programming language while mastery. So that's what now you go through this paper. But if you already done the course completely here, please solve it with the time limit. And when by mid of the course, or maybe by after 2-3 weeks now, I'm going to discuss this paper test 1. I give 3 tests for this basic course now. Similarly, advanced as well as pro, I'm going to take up what they call 3 more tests later on when I open up those courses here. 3 tests, if you can able to finish stuff, that gives much more confidence for random questions anywhere in the the syllabus of that specific program here. That's the discussion I want to make it up as far as what they call. So this second part here. So third part is I need to log in. So we need to log in here. So I'm asking this guy, he'll log in it up. So once he log in it out here, then I'll take your live questions anyway here. So meanwhile, anything else? I'm just thinking of it. That's all. So let me take up live questions now. I'm logged in. So I checked where zeros in nums1 and then pushed num2 into then and sorted up. The first question, let me just go up. And I think assignment questions is okay. Then I checked where are zeros in num1 and then pushed nums2 into n and then sorted up. Oh, okay. So his question is, in this so-called assignment number merging problem, is saying that, so where are zeros in nums1 then push nums2 into and sorted up. That cannot be done. The reason is, if you copy these elements now, if you sort it up, what are the complexity here? Sorting takes now what they call n log n here. This is too much of complexity. Even we are telling n times here. So solution is working, no doubt, but copying this and sorting it up is definitely not accepted. It's n log n complexity. Copying takes some time, and again what they call sorting takes a lot of time here. But already they are sorted up. Why don't you use this property? The intent of the question is, the tricky part of the question is how to use the advantage of the 2 pieces are sorted and make a fast algorithm here. And that's what I think is asking out here. Next question here. In binary tree, construction time complexity is big O of log n. Can I reduce to big O of n? So tree construction time complexity is big O of n log n. Binary tree construction, first of all, why is it n log n? Can I reduce to big O of n or not? Okay. Binary tree and BST, there are 2 things now. Let me clear the difference first here. Binary tree versus BST. So this question is clearly what they call. So I'm just looking at the questions anyway. So some are comments are there. Binary tree construction time complex big O of n log n. So let me write it up. N log n. First of all, binary tree, how do you add in elements? There are 2 things now. Binary tree, BST. You have to differentiate this clearly. Binary tree versus BST. In binary tree here, let's say if 10 element, 15 elements, 20, 30, 40. If these elements comes, we don't have any order here. First we make it as a root. 15 comes up. Where do you insert it up? Right or left? No rules here. You can toss a coin. You can go to left and right. You can move there. Next 20 comes up. You can toss a coin. You can go there. This is what traditionally we use it up. The binary tree, only binary tree if you want it up. But if you want a BST anyway here, then surely 10 and 15 comes up, higher elements go to right side, we insert it out here. 20 now, right side. And if you balance this out here, this takes n log n complexity here. That's why. So a BST construction, surely what they call n log n, we can guarantee finish. Binary tree even n log n, we cannot do it up. We need much more than n log n anyway here. At least assume that your question here is using this kind of strategy. At least in BST, you insert elements now, even to adjust this balancing, it all takes log n. Totally n elements now, n log n complexity. But your requirement is, can you do in n time or not? So n time binary construction is not possible here. The reason is, after insertion you need a balancing here, the balancing part. But if you don't need a balancing anyway here, even then n you cannot do it up. There's no way. N algorithm is not possible. Linear construction is not possible here. If I go what they call incrementally here. But if a batch is given it up, I'm thinking a batch of data, whole array is given completely in sorted order. So then you can think of what they call linear algorithm here. I think we have discussed in one of the videos now. If array is sorted now, BST is so simple, go to middle anyway, make it as a root. So construct the tree for it, construct a tree for it. Again go to the middle in the left part, make a tree, right side also you continue. So when batch data is given, which is sorted again here, then BST construction takes n time. But when random data is thrown, the only possibility is incremental construction. Means element by element you have to insert it up, then you have to balance it up. N time it's not going to work. A binary tree or BST, you cannot do it up. But this is possible. This is a ordered data and then a batch. A batch means upfront a whole array is given, a batch of data, then an algorithm is possible. I think that's what your intention. I have discussed in one of the videos in BST, sorted array, how do you get an algorithm now? You go through the video, you get the details of how this can be done. So that's what is question. Could you please share us even the old topics which are attended in the live classes? Okay. One request, every week please discuss at least one assignment paper. I'll keep that. That's what we started. I think every week I'll go through the assignments now. Once assignments are over, then I'll take up practice problems. In class, you taught how to convert recursive algorithm to iterative and vice versa. Please record a video on that as well. That is part of advanced course. So in top 20 advanced, we kept it up. That's why I didn't take in the basic course. Recursive, non-recursive needs little more deeper coding anyway. That's why we'll bring it up in advanced course. How do we are covering DP problems? DP is completely in advanced. Basic course, the reason why I really separated this one, basic is like if you are new to the coding anyway, you want to really understand fundamental problems first. I don't want to bother people with dynamic programming, with the complexity in the first course itself. Once you're comfortable with the coding anyway, DP looks like casual work. Oh, is this DP? Because you all know recursion very well. By the time you come to the DP, you just play with the DP very quickly. That's why DP, only few problems are given in the first part, only 1D, also 1 or 2 examples. But second part, I'm going to take a definitely very deep, and third part in Pro, I'm going to take it up in much in depth anyway. So you got to wait until that course is finished up. Next question. Last one, BST is possible if I got a value in mid. So order of n is possible. Yes, exactly. That's what Rahul. So last one, BST is possible, correct? If I got value in a mid. If you got a value in a mid means obviously you need a sorted array. If you don't have sorted array, how can you get it up? This is called batch construction. Every data structure, 2 ideas you have to be careful. Linear or incremental construction is one, batch is different. Linear, all you have to do is only one element at the time is available, dynamically comes up. You got to add or delete is one. Sometimes you have a data up front, like you're reading from file, you got data, you want to build an index now. You make a batch construction. That's common for any kind of data structure. So this first algorithms are possible if batch data is available. Your question is only on BST. Later on, we are going to see B tree is there, B plus tree is there, a lot more indexes now. All of that, batch construction is different, and again, incremental is different. I'm sure if you recall priority queue also, a array is given, how do you build a priority queue? If element by element is given, how do you build a priority queue? There also, I discussed 2 algorithms now. One is very slow, incremental n log n. and batch n time here. Most data structures, these two distinction is very important, and your question is very clear, and in general that's how you can able to get clarity. Incremental versus batch, you understood that. To learn design patterns, architectures, which language is better learn? I know Python. If those things, if you teach in Java, it will be difficult for people like me. If I take design patterns course in online, I'll take design patterns course in all the languages now. That's why I told you online, whatever language you're comfortable, go through that language here. So even if I take design patterns, I'll code in each of the languages, CPP, Python, and also Java. It's like the way I have coded top 20 here. First thing. Second thing is design patterns. For understanding, I do coding, but mostly after getting some understandability, you got to focus on UML innovation. The UML is the the key. I'm thinking if I do in online, I take what they call the tools for UML construction. I'll focus on more design at the graphical level, but at some points when coding is required, wherever coding, I code in all three languages. So you should not bother. So in offline, I don't have a time because very limited slots are there. I cannot take in all languages here. But online, like the way I do here, same thing I keep recording up. I'll put in everywhere here. So that issue you won't find it. Next, can we give weights to alphabet, and if the sum of the weights of string equals sum of the weights of strings of an anagram, it is a match and we can return the index. This is for anagrams problem. Oh, that you cannot do. There's a serious issue. So ABC now, if you give weights now, letters, each letter I give weight. ABC 1, 2, 3, fine. Now I'll give one more here. A, so sum equals 6 now. Now I'll take one more guy now here, which is 6, right? 4, right? B, D. In your order, B is 2. This is 6 now. This also gives 6 now. Summation is dangerous. So here 1, 2, 3 is available, 2, 4 is available, 6 is available here. That means two distinct combinations give same sum, but they're not anagrams actually here. So that's why giving a unique kind of assignment for each letter and then summing and all of that, so tricks will fail. Even length same also, you can find a counter examples now. That's why the tricks will not work. You got to sort, or you can use a character by character matching like a hash, one of them here, or some array you maintain counts of each. Sorting is a quick trick in a way here. In anagrams, you want to quickly check it up. That trick will fail. And that question, yep. So that's what Kalyan's question. That's answer anyway. Unbalanced binary tree is possible in big O of n, right? Unbalanced binary tree. So what is unbalanced binary tree? So obviously you can do on this simple. Take a node, 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 take a node. What is the problem? This is also binary tree. This is definitely n. But what is the use of this? So that's why trees really make sensible. If really make it up, what now here? Log n height. Otherwise, what the whole point of trees, non-linear structure, it's like a linear structure in a way. That's why it's not useful. That's what I'm saying here. So even though you want to construct tree incrementally here, it's not going to work. Unbalanced trees, theoretically, maybe you can talk about practical useless. Next. Describe that a time algorithm that given a set of n integers and other integer x determine whether or not exist the elements in S whose sum is exactly S. Describe a time algorithm that given a set of integers and another integer x determine whether there exist two elements in S whose sum is exactly S. Okay. Maybe this is in one of the topics we discussed, I guess. Is asking the time complexity. I think the way I have seen the question, he wants to know time complexity given a what they call a set of integers, another integer x now, whether pair sum equal x or not. That's what the whole point anyway. To find a pair sum equal x or not, what is the complexity issue? So this is what the problem. 5, 6, 2, 1, 8, 9, 15, 12. Now I'll give you, let's say sum equal to, let's say 9, 8 plus 1, 9. So how do you solve it? That's what two sum problem issue. It's not sorted array, it is unsorted array issue. Sorted array I explained, unsorted array also, I think videos it is there. But just to give you a clarity and the complexity now. So one best is the single scan algorithm here. Single scan, what do I do? 5 is available, but the mate with 5, which is gap 4 is not available in a it's not available. I keep 5 because in future if 4 comes up, I can able to find in the set. Now 6 is there, 6 again, 9 minus 6, 3 is not there, insert 6 and evasion. Next 2 is available, 9 minus 2, 7 is not there, insert 2 now. 9 minus 1, 8 is not there, keep 1. 9 minus 8, 1 is already there. Stop the algorithm here because you got a pair now. So once you got a pair, we got an answer, but what are the time complexity? I think the question that guy intended up is, what are the time complexity? What are the total operations you are doing up? I'm using data structure driven approach here. So I just make one scan here. While doing a scan, what are I doing at each element level? I take this element, I take a sum now here. So 9 minus 5, 4, I'm going to check it up. To check it up, I need to make a call like a contains or a find call. And I need to do add also or insert here. We need this call. 2 calls per element we require. How many elements in the worst case here? So n elements now. N elements now. Each element 2 calls. And which calls you are making up? You are making data structure calls now. If I use a hash set with a good hash function now, with good internal implementation, they take order of 1 in evasion. That's why we take it a big O of 1. That's why the complexity here, we write it as all of them constant and hidden. So we write big O of n. That's why. So to check 2 elements, sum equal S or not here, we'll take order of n if I use hash set data structure. So a good hash set implementation of language have it, they give this complexity. So that's what. So describe a time algorithm that I guess he wants a time complexity or you want a best algorithm, that both are answered here. When can we expect the following courses will release? Language learning, language learning by 28th, language learning will be released. Can you please add bitwise operation example? Not simple example, in-depth bitwise is required. So again, advanced course I kept it up in syllabus. Okay, bitwise programming is critical. Again, basic course, very fundamental things I kept it up. Design patterns, I tell you before December, at least first part of design patterns, first, in the total series now, first course will be taken, which is obviously design patterns, the over design patterns now, I'll take it up. How many questions a day should we target to code? There's no such kind of answer. How many questions? So you target to code. Because when you start your coding, maybe even one question to code by by your own thing, by your own way for day is difficult. Because till that time you start coding here in college, they keep on asking write, question answer. Exam also same by adding on. Then suddenly you see the coding first day. Now your mind, you're not used to do that. First code also you may struggle, your syntax error, your variable declaration, everything is a trouble. The video's advantage is the way I coded up. Now if it gives an immediate thing, oh, this is how I'm coding up, now that's how I'm practice it. So if that's what you take the time, you can take the time off, lot of time you can save it up if you see someone else coding it up. That's whole intent of live coding anyway, in a videos now. So with that, maybe a week and a month of time, if you keep practicing slowly without, going out of it anyway, after some point here, per day you can do 4 or 5 questions now. Even after some point of time, you don't have to code also. Once you really get comfort, confidence that I can convert my thought into code, coding is not required. Until that fear goes out here, you must keep doing it up. It depends on individual person and the time or the focus you have at the moment and the kind of expertise you have it. For working guys who are doing coding anyway here, maybe per day they can do lots of questions. There's no answer for it. It's subjective issue. But I told you, once you feel confident that I can code anything, from that point, stop the coding. Only focus on building algorithms now. Quickly, very rarely, if you want the best solution, you can code it up. Okay. So how many questions? That answer is done. Next one, can you please explain how to calculate maximum width of a binary tree? I think that assignment question, it's part of the assignment, I guess. Given that, I'll take it up in a binary tree assignment. Mostly next week I'll take up topic by topic. So by that time you please work on it. Otherwise I can put answer on the Q&A section. Okay. So that's what we have it up here. So that's all the questions. I have it up on YouTube here. So next week, so I'll take up other assignments here from Adhoc, the next order, exact order. So we'll discuss that assignment. Before that, I recommend you to go through all the videos now. You work on assignment once now. If you come to the live here, you really get the issues what are your mind here get cleared off. That's why you can, without obstruction, you can able to finish up the course and you can able to build confidence now. That's what the recommendation here. Please do that. This test, I told you, you have to attempt this at least by mid of the course or 70% of the course is over. I see the questions are intermixing all of that, all the topics. I don't want to discuss now, even before you really finish those topics and everything. But just have one look on the, the test. You get a clarity on how tricky the questions will be, even online, if they give objective also. That's the intent of the giving paper. So that's what you want to discuss as part of today's live session. Next Saturday, we'll meet with the new topics.